Okay. So for those of you that want a couple of extra quadratic formula examples, we'll do 3 of them here for you. We'll do one of each kind so that you have another example to look back on. So remember, the very first thing that we always want to do is we want to identify what A, B, and C are. So remember, if there's no coefficient on x squared, we assume that it's a 1, so A is 1. Remember to use the signs. B is -7 and C is +4. So I won't sing it for you, but remember, here's the formula. X equals opposite of B plus or minus the square root. B squared minus 4 times A times C, and the whole side is over 2 times A. So then all we're going to do is, first step is to replace. So we're just going to take everything from here and we're going to plug it into here. So remember to take the opposite of B. So if this is -7, when we plug it in, it becomes a +7. Plus or minus the square root.
Jacob O'Connell, please come to the main office. Jacob O'Connell, please come to the main office.
Okay, so B is -7, so -7 squared. Minus 4 times A is 1 and C is 4. And then the whole thing over 2 times 1. Alright, so second step is we're going to start to simplify the discriminant, right? Remember, that's the part underneath the radical sign. So x is equal to 7 plus or minus square root. So -7 squared, remember, anything squared is always going to end up positive, so +49, and then we want to multiply all 3 of these together at the same time. So -4 times 1 is -4, -4 times 4 is -16. So whatever sign we get from here, that's what we put with the number here. And then all over 2. And remember, our discriminant isn't complete until we have one number under the radical sign, so we want to combine this first before we're done. So x equals 7 plus or minus the square root of 33 over 2. And then the next thing we want to do is we want to take care of this radical here. So the first place we need to think about is looking on the card. So is 33 a perfect square? Well, if we square root 33 in our calculator, we would get a decimal between 5 and 6. So we know that 33 is not a perfect square root. So the next thing we would need to look for is the factors of 33. So if we were going to simplify 33, the factors would be 1 and 33 and 3 and 11. Remember, this one we can ignore, and the only factors of 33 are prime numbers. So 33 can't be simplified any farther. So then that means that our answer is just this. So x equals 7 plus or minus the square root of 33 all over 2. Alright, for the next one, again, we want to identify what A, B, and C are. So A is the coefficient on x squared, B is the coefficient on x, and C is our constant. Okay, so again, x equals opposite of B plus or minus the square root of B squared minus 4 times A times C, and the whole side is over 2 times A. Okay, so now we're just going to start substituting. So x equals the opposite of B, the opposite of +5 would be -5. So -5 plus or minus the square root of 5 squared minus 4 times 2 times -7, and then the whole thing is over 2 times 2. Okay, again, we're going to start with the discriminant, which is the part that's underneath the radical sign. We're going to simplify this part first. So x equals -5 plus or minus the square root of 25 -4 times 2 times -7. So -8 times -7 is positive 56, and then 2 times 2 is 4. Okay, our discriminant isn't finished yet because we need one number underneath the radical sign. So we're going to simplify that part. -5 plus or minus the square root of 81 over 4. And the next part again is to look at the radical. Okay, so in this case, 81 we know is a perfect square root. So I'm just going to move this up here so we have a little bit extra room. So x equals -5 plus or minus, and instead of 81, this time we're going to write what the square root of 81 is. And remember, when we take the square root of a number, the radical sign goes away. So -5 plus or minus 9, and then all over 4. And then this is the part where this guy comes into play, right? So we know our discriminant is positive, which means we're going to have two solutions. And because it's a perfect square, we're going to have two rational numbers for our answers. Okay? So -5 plus 9 over 4, and -5 minus 9 over 4. So -5 plus 9 is positive 4 over 4, which is 1. So one of our answers is 1. And then over here we have -5 minus 9, which is -14 over 4. And this can both be reduced by 2. So -14 divided by 2 is -7. And 4 divided by 2 is 2. So there's our two answers. Alright, and then the last one that we're going to do is number 8. Oops. Take that off there. Alright, so the last one again, we want to start off identifying A, B, and C. So A, because there's no coefficient on the x squared, A is 1. Remember to take the sign with B, so -4, and take the sign with C, so that's -7. So x equals the opposite of b plus or minus the square root b squared minus 4 times a times c, and the whole side is over 2 times a. Okay, so then substituting, we get x is equal to, remember it's the opposite of b. Our b is negative, so when we plug it in, we're going to get a positive 4 plus or minus the square root b squared, so we're taking -4 squared minus 4 times 1 times -7, and the whole thing is over 2 times 1. Okay, so remember we want to start with the discriminant. So x equals 4 plus or minus the square root of anything squared is always going to be positive. So even though we're squaring a -4, remember, squaring something means take it times itself, so -4 times -4 is positive 16. And then remember, we want to multiply all of these three things together all at once. So -4 times 1 is -4 times -7 is positive 28. And the whole side is over 2. 2 times 1 is 2. Okay? Again, we're not done with the discriminant yet because we need to simplify. So x is equal to 4 plus or minus the square root of 44, and then the whole side is over 2. And again, I'm going to move this up here so that we have a little bit extra space. So x equals 4 plus or minus the square root of 44 all over 2. Alright, so when we look at the square root of 44, 44 is not a perfect square. So the next thing we need to think about is whether or not we can find the factors of 44 and if any of them are perfect squares. So 44 would be 1 and 44, which remember we can ignore. Okay. We also have 2 and 22 and 4 and 11. And those are the only factors of 44. So if we look, the biggest perfect square on this list would be from 4 and 11. So we would have the square root of 4 times the square root of 11, which is equal to 2 times the square root of 11. So all we're going to do is we're going to take this out, and we're going to put this in its place. So since these two things are equivalent, we can replace that. So we're going to get x equals 4 plus or minus 2 root 11 over 2. And then the very last thing that we need to do is, remember, we need to look at all of the non-radical pieces and think about what they all can be divided by. They have to be divided by the same number. So in this case, they can all be divided by 2. So 4 divided by 2 is 2, plus or minus 2 divided by 2 is 1, and then bring the root 11 down, over, and then 2 divided by 2 is 1. Alright, so hopefully that gives you a little bit more to practice with and a little bit more to look back on. If you have any questions, on Monday we'll do review for the final, and you guys will have a chance to ask questions then. So have a good weekend.